Hello, everyone, and thank you for joining me and Jim for this webinar, which is supposed to illustrate how smart technologies and robotics can help small and micro businesses. Yeah. Okay. Sorry about that. So about this series of webinars, they're a collaboration between the William J. Clinton Leadership Institute at Queen's Business School and the Digital Transformation Flexible Fund. And we've already had two of those webinars, one covering the blockchain technology, the other one big data analytics. This webinar will be covering smart technologies and robotics. And then later this month, we will have three other webinars, one covering artificial intelligence and machine learning, the other one immersive technologies, and finally there will be a workshop where you will be able to articulate your digital transformation strategy. So you have that QR code at the top right corner of the screen, and you can actually register for the other webinars in the series. For the introduction, so my name is Andrei. I'm a lecturer at Queen's Business School in Strategy and Innovation Management. And Jim McWilliams from Infofort will be joining me to provide further insights into robotics applications. So a few things about the Digital Transformation Flexible Fund. It is a grant scheme that aims to stimulate the digital transformation of small and micro businesses. So it recognizes the financial barriers that these kind of businesses will encounter in their attempt to adopt new technologies, Industry 4.0 technologies, and it aims to provide some financial support to alleviate these difficulties. Very importantly, the grant scheme is targeting a digital transformation and not simply the digitization of existing businesses. Okay, so the difference here would be digitization means moving from a physical format or an analog format to a digital format, and that kind of digitization is, so for example, like transferring orders or invoices from a paper format to a digital format, that is not regarded as a business transformation, as a digital transformation, but merely as the digitization of existing operations. What would count as a business transformation would involve the adoption of these Industry 4.0 technologies, which include big data analytics, smart technologies, Internet of Things, robotics, immersive technologies, blockchain, and so on. And with the adoption of these technologies, businesses will be almost inherently going through a process of transformation of their organizational processes, of their products, services. There can be improvements in the quality of the products and services that they're offering. There can be substantial cost reductions and so on. And so what we're looking for is this fundamental digital transformation of the businesses and not the mere digitization of existing operations. Further, the Digital Flexible Fund is a capital grant scheme, which means it only covers capital expenditure. It doesn't cover operational expenditure. And it consists of funding pot of 7.5 million pounds, supported by all local councils in Northern Ireland, and it is administered by the Newry, Mourne and Down district councils, and it is supported by the InvestNI. In terms of eligibility, all companies based in Northern Ireland, which fall into the micro and small category, which means between 1 and 49 employees. These companies have to be VAT registered, and they have to be trading for at least 12 months. If you have, or your organization has not been trading for at least 12 months, you may not be eligible now, but you may be eligible for future calls. So there are 5 different calls that will be happening. We are now just ahead of the 3rd call, so you may become eligible in the future. The scheme, the funding scheme is open to all industry sectors, except primary agriculture, forestry, and fisheries. This capital expenditure has to be part of a digital transformation plan of the business, and it has to be centered around one of these 6 digital technologies. And again, very importantly, it's about capital expenditure, which can consist of equipment, hardware, devices, also software packages, but not cloud-based applications for which you may end up paying a subscription rather than making a capital investment. And there's always also compliance in terms of state aid and subsidies, meaning that your organization should have received less than, I think the limit now is 315,000 pounds in the last 3 years. How the process works? Well, it's a 6-stage process. We are now at the pre-application or even before the pre-application briefings. These briefings will be happening in all counties from June 17th at different dates, and they will be provided by the Clinton Leadership Institute. Following these briefing sessions, you will be invited to express your interest. You'll have to describe very briefly what your project is and how it feeds into this digital transformation. And based on that, your expression of interest will be assessed. And if it's accepted, then you'll be invited to apply, to make a full application for the funding, which will then be assessed independently by Queen's Business School and by the local councils, and ultimately by a joint panel between the Clinton Leadership Institute and the local councils. Once your application is deemed successful, you will receive a letter of offer. And after this point, you should be looking to make your investment, buy the equipment that you need, and then you can claim back the investment. So, as you probably know, the DTFF grant scheme funds projects, offers funding between £5,000 and £20,000, and this investment, these sums have to cover up to 70% of overall investment. So your organization has to cover the rest of the 30% of the investment, or a minimum of 30%. You can spend more, but you can claim up to 20,000 pounds. So as I mentioned, there will be a session, some pre-briefing sessions that will start June 17th. These will be then followed by briefing sessions in each of the local councils in Northern Ireland. And you have this QR code, and you can scan it and get more information on these briefing sessions. Regarding today's webinar and the agenda, we'll start by discussing a few things about automation and smart technologies and robotics. I will then continue and discuss applications of robotics, cobotics, smart technologies within manufacturing contexts. And then I will be passing on to Jim, who will be providing further examples regarding robotics applications outside the manufacturing context. And then I'll be talking briefly about whatever help and support is available for your applications. And then we'll have a short question and answer session. So in terms of key concepts, we're looking at automation, which has been around for several decades now. And it essentially means conducting production processes with machinery or robots, which are controlled almost exclusively by computers with minimal input from humans. Right? In the original interpretation of robots here, we generally meant the application, the combination of concepts like memory and mechanical actuation, meaning that robots will be doing repetitive tasks under the control of the computer. In the recent context, robotics actually implies smart technologies, the use of all sorts of sensors like video cameras and 3D surround vision and tactile sensors, which enable the AI-powered robots to make sense of their environment and then improve the performance of a particular process. With cobots, it means basically collaborative robots. The essential difference is that these robots are safe to work side by side next to human workers. As you probably know, when we have a fully automated assembly line, these robots work in isolation, and if a human needs to intervene, then the full production line needs to be stopped because it's otherwise not safe to intervene. With cobots, we have these safe collaborative robots that don't have to work in a confined or contained environment, right? And they have substantial safety features that are embedded within their software. To provide a brief overview of industrial robotics, this is Gargantua. It's the first patented industrial robot in 1937. What it did is stacking wooden blocks in different patterns, and it was actually programmed by the use of paper tape with punches in it. The next one is Unimate. It is the first industrial robotic arm. It was introduced by General Motors in their New Jersey plant in 1961. And what it did was move die castings from one place to another and then weld these die castings onto auto bodies. This is the first robotic arm that was controlled by a microprocessor. It was developed in Europe in 1975, and it actually was equipped with Intel's first chipset. From this stage onwards, we're looking at increased automation, heavy use of robotics on production lines, moving towards full automation. So that was between 1980s and the first decade of the 21st century. And this brings us to Baxter, which was launched in 2011. It wasn't a particular success commercially, and it was discontinued in 2018. But what was remarkable about Baxter was that it learned from human demonstration. So in order to program this robot, you had human users grabbing Baxter's arms and showing him what he needed to do. And then based on that demonstration, he would learn and repeat the actions while improving the process by adding up speed, accuracy, and so on. In the past decade, we've moved towards the humanoid robots, and the point of why most robotics companies have moved towards humanoid robots is because most of our environment is designed for humans, which means that humanoid robots are more likely to adapt and function efficiently within our environment. And so this is Atlas, the robot developed by Boston Dynamics. The thing about Atlas is that it excelled in movement accuracy, but he didn't actually learn. He relied on pre-programming for everything that he did. From Boston Dynamics, also we have Spot, which actually was far more successful commercially than Atlas. Because it's used by companies like BMW, Hyundai in their plants, and Spot walks around with a number of cameras and sensors, and it collects data from various points in the factories of BMW and Hyundai. This is Digit. It's a robot developed by Amazon to manipulate and move items in warehouses. This is now Optimus, Tesla's robot, the robot that Tesla envisions in working in its production lines. And lastly, we have Figure One, which is a robot developed by Figure AI, a startup company that has gained a lot of traction in the past year. It attracted investment from OpenAI, from NVIDIA, and it has a commitment from BMW to use these robots on their production lines once they become available. So from this overview, there are two things that we should take up. First one, we're looking at substantial improvements improvement in computing power, which is underpinned by a new technology in chip manufacturing called extreme ultraviolet lithography technology, which allows the printing of very, very small patterns on computer chips, which then increases the computing power of these chips. And then we have NVIDIA, which is now the most traded stock in the world, which has developed this new generation of computer chips that are actually powering most of AI applications out there. And in fact, NVIDIA actually has a set of chips that are designed specifically for autonomous robots. Now, some of these, the features that these industrial robots have are that they are smart. Right? So that's where the smart part of the technology comes in. They are equipped with cameras, 3D sensors, tactile sensors that allow them to make sense of their environment and make choices, optimal choices in these environments. Very importantly, most of these robots now they come up with basic manipulation and perception models and reference libraries which are provided by NVIDIA. And so in the computer chips that power these robots, now they come up with these basic models that allow them to learn manipulation, the manipulation of objects, and the perception of the surroundings. Another thing is some of these robots learn directly from human demonstration, right? So Baxter was the first cobot that learned from human demonstration, and now this kind of training of robots is increasingly common. Further, these robots can be programming by uploading the CAD data of the parts, components, products that they are supposed to maneuver or process. And so if we put together all of these features, all of a sudden the programming of robots becomes less of a problem than it used to be. And so we have the basic programming that comes from the chip developers, and then there are various layers of programming that can be added. They have built-in safety features like anti-collision systems, which makes them very safe to work around. And then they, through the Internet of Things, they interact with other pieces of machinery within their environment, and also send, capture and process data that is then can be integrated with ERP systems or MRP system, material requirements planning systems, and so on, in order to optimize operations in a production facility. Most of them can be quite lightweight, which means they can be moved easily by hand from one part of the shop to another where they're needed, and so on, which adds a lot of flexibility to this process. And the last and perhaps one of the critical features of these robots is that they are multi-purpose, or they are increasingly multi-purpose. Up until the last decades, we were looking at specialized robots that were performing one task exclusively. Now, with the advent of these humanoid robots, these robots can perform a multitude of tasks. In fact, Figure AI have made it their strategic objective in pointing out that, well, it's not effective to have millions and billions of robots that perform a single task. It would be far more effective to build one robot that can perform millions of tasks, right? While that robot may be somewhat distant into the future, multi-purpose robots are available, so we can you can have robots that manipulate parts and do assembly work. You can have robots that do drilling, milling, and grinding of parts, and so on. So we're no longer looking at the one task specialized robots anymore. Now, what does this mean in terms of benefits? Well, clearly we have quality improvements, especially when we were talking about precision, accuracy, the consistency of the work. These are areas where industrial robots can help immensely. Also, in terms of productivity, right? Increasing the speed of the production and the volume. Also, there are benefits in terms of safety, right? Wherever strength, endurance, handling of harmful or dangerous materials is required, industrial robots will come very handy. They can provide also cost improvements, right? As we increase the speed of production and the volume of production, the cost per unit is likely to go down. In addition to that, the cost of these industrial robots is going down. So a study shows that it has halved over the span of a decade, with further decreases in price being expected in the near future. So the study conducted in the United States showed that the average price of an industrial robot is somewhere in the vicinity of $23,000, which actually is in the ballpark of the DTFF funding scheme. Okay, so what does this mean for small and micro businesses, right? When we're talking about full automation, that generally makes sense when we have flow or continuous production, when we're making millions and millions of units, right? And clearly this is not the case for small and micro organizations, right? Even if you could produce this type of volume, probably the market will not be there. So as these micro and small organizations operate in a per job basis or one-off products or batch production, where a limited number of units of a specific product are produced and then a different batch is produced and so on. This is where full automation doesn't make sense economically, and it's not even that much desirable, right? Here, partial automation makes far more sense. And so what partial automation means, assume you have a productive process involving 6 steps, right? You don't want to automate everything, right? You may want to introduce these robots at 1 or 2 steps in that process, usually wherever the pain points are, wherever the most complicated part of that production process is, wherever strength, endurance are required, wherever precision, accuracy is required, that's where robots can help and contribute, right? So identifying these pain points in the production process and then bringing in robots, smart technology to perform those tasks enables the small organizations to use their workers, which almost always are in short supply of, and move them to other steps in the production process, usually where they can provide hand finishing and customization, which all customers love and they are willing to pay higher profit margins for. Right? So it is a bit of a strategic process in choosing which parts of your production process should be automated or makes logical and economic sense to automate or to use robots. Now, obviously, this is a creative process. What I can provide as illustration, one, it's a historical example on how these production lines can be reimagined, and one is quite a recent development. So some of you may be familiar with BYD. It is currently the biggest electric vehicle manufacturer in the world, and one of the biggest, if not the biggest, lithium-ion manufacturer in the world. It's a Chinese company that at the beginning of the 21st century was nowhere to be found. It was just a small Chinese competitor with with minimal prospects on the market. They set out to make batteries for toys, and they licensed the nickel, cadmium, and lithium-ion technology from Japanese companies for that purpose. But whereas Japanese companies were using fully automated production lines, BYD went and implemented, licensed only the essential pieces of equipment in the production line, and they remove everything else, including conveyor belts, and replaced it with human labor. While their production line involved 10 times more workers than the Japanese production lines, the batteries were 8 times cheaper. And more than that, and more importantly than that, the BYD production lines were very flexible in the sense that it allowed the company to move from one size, one shape of lithium-ion battery to another very quickly. For the Japanese companies that had the full automated line, moving to a different type of battery required the full retooling of the production line. It cost millions of pounds and took months to do. For BYD, they just changed the software in the core equipment and then retrained the workers. Within 2 weeks, they could move from one type of battery to another. So that allowed them to provide highly customized batteries for their customers. And needless to say, they skyrocketed past the Japanese competition. The other example on how production lines can be reimagined, we have this notion of microfactories, which is becoming increasingly important. With microfactories, the principle is we don't really use the moving assembly line introduced by Henry Ford, where products were moving from one workstation to the other. Instead, because we have now multi-purpose robots, products can be produced in a stationary cell, in one or two stationary cells, where these robots perform a multitude of tasks in the same location. Now, this means huge savings on real estate. In 2023, Hyundai opened one of these microfactories in Singapore, where real estate is highly expensive, and there they are manufacturing electric vehicles there. So this is another way in which these smart technologies, these multi-purpose technologies, can help small organizations, right? You can set up your shop in an urban setting next to your suppliers, next to your customers, and you can perhaps avoid high costs with the real estate, with the plant, and with logistics. So factors to consider we can when deciding to go for to implement robots on your production lines. Well, the full workflow, and thinking of where these robots would fit in best and where they would contribute to your operations best. Usually, as I said, it's where the pain points are, where difficult tasks need to be performed with high accuracy and great consistency, right? And these are where the sources where quality improvements can be reached. You can also think on how to optimize existing resources like workers, real estate, by using these robots. Obviously, you have to consider the return of investment. So this change, this shift to robotics has to be economically viable. Your investment needs to be amortized without making very, let's say, without highly optimistic expectations in terms of growth in demand. Right? And very importantly, you have to have a strategic overview. How can these smart technologies help in creating a competitive advantage? Right? Of course, there is the increase in productivity, which can reduce costs. But since small and micro companies, they are unlikely to produce big volumes, I think the competitive advantage that could be created is around quality and customization. So improving the quality of your products, your services, and adding a layer of customization which bigger organizations may not be able to provide. So I think at this point, I'm going to hand over to Jim. So Jim will show that the same principles can work outside the manufacturing context. So the same ideas work in, let's say, a variety of other settings. So, Jim.
Thank you, Andre. Okay, so in 1989, the Berlin Wall was coming down. Meanwhile, over in Munich, Bavaria, I was the spuler. Spuler means washer up. In 1989, I was washing dishes in the BMW factory in Munich. That was my job. Now, there was a few things that were very fascinating about working in that huge factory in 1989. The first thing was that on every corner, there was hydration stations. And in those hydration stations, you could get sparkling water, still water, lemonade, or ice cold German beer at any time, day or night. So the other thing that was very fascinating was the level of automation and even to some extent robotics in 1989. Even my dishwasher machine was a pure marvel. The, the workers would put their dirty dishes on this conveyor belt, and the dishes would stay on that conveyor belt and they would move through a process of getting washed. And then they would come out the other end, clean and dry, still on a conveyor belt. And my job was to stand at the end of that conveyor belt, grab the dishes before they fell off the end of it, stack them, and put them in a trolley where another spuler would take them away. Now, it might have been a combination of the beer or it might have been the speed of the conveyor belt, but I wasn't too good at that job and there was a lot of broken dishes. So within a day or two, the kitchen manager fired me. But BMW, they seen that I had some potential. And the very next day at 6 o'clock in the morning, they took me down to the production line where they were making the 3 Series BMWs. And at that time, I didn't speak any German. They didn't speak any English. But within an hour, they trained me on how to use this kind of semi-autonomous spot welding machine. And within about 3 days, I was as good as my German colleagues. And I was doing about 11.5 to 12,000 spot welds per shift. And looking back, it was really easy to do because the machine was designed and made in such a way that it was easy to operate. I had no machine experience. One day I was a dishwasher. The next day I was spot welding the chassis of 3 Series BMWs. Now, I have a client called Martin. And Martin, fabulous guy, extremely intelligent. And he is a qualified accountant, he's a qualified auditor. He has worked for some of the big 4 accountancy firms around the world, and he now has his own business in the aviation industry. Highly successful man. So just last week, I was doing some work for Martin, and I needed some information. So I took a Google document, I wrote a few questions, and I sent the link to Martin. And I said, Martin, please just write a few bullet points under each question. I'll do the rest. It'll take you 5 minutes. So about 2 days later, I got an email from Martin, and the email had an attachment. I opened the attachment and I was horrified to find that Martin had he had pressed the link to the Google document. He then printed it. He'd then taken a pen, an old style pen with ink. He'd written all the answers in longhand, and I couldn't even read his writing. Then he'd scanned it, and then he'd emailed it to me. So I called him, and I said, Martin, what did you do that for? It was just going to take you 5 minutes, just a few lines. Why didn't you just put the information in the Google document? He says, I don't like them things. I don't like technology. And so when I look at the reasons that prevent people from enjoying the benefits of technology, from my experience, it's 90% perception. It's 90% just the mental attitude to try new technology or not to try it. There's a kind of an apprehension there. It's a bit like, riding a bike for the first time or jumping in the big swimming pool for the first time. But that really what I see, that's the main thing preventing a lot of people from doing it. But it doesn't have to be challenging. If I can go from being a spuler one day and being taught without knowing any German how to use this huge spot welding machine, then anybody can do it. So the other thing that a lot of people, we use a lot of fancy words. We talk about artificial intelligence. We talk about blockchain, and these words can be quite intimidating, and they can kind of feel very futuristic, like you're watching Star Trek or Star Wars or something. But really the future is now. If you remember, it's not too long ago we all had checkbooks, and then after checkbooks there was debit cards and credit cards. And but if you went to the shop, they had those big clunky machines where they put the slips of paper in the machines. And then it moved to, rudimentary scanners. And nowadays you just scan your phone because you have mobile payments. Well, if you look at the image on the left, the X-ray of the hand, and you'll see there's a basically a microchip between the index finger and the thumb. So that is now your bank details. Scan your hand. But it's not only your bank details, that's your passport, it's your driving license, it's your medical records, it's your security pass to get you into Queen's University, it's your security pass to get you into your place of work. Now, that may sound very futuristic, but there's over 50,000 people today using that technology. The other image on the right, the guy with the funny thing in his head, that's a real picture. His name is Neil Harbinson, and the funny thing in his head is an antennae that's permanently fixed into his skull. Now, Neil done this originally because he was colorblind and he wanted to see color, and that's how it started. But now Neil is permanently connected to the internet. He can not only see color, he can see ultraviolet light. He can receive direct image or direct information from a satellite in space. And Neil has, when you listen to Neil talk, and he'll say he has senses that an ordinary human doesn't have. Neil was the world's first cyborg, meaning part person, part machine. Neil became a cyborg in 2004. So the point of me showing you these two slides is not to suggest that we all become a cyborg or that we all go and get microchipped. Although I do think there'd be a lot of convenience in it, but it's just to show you that the things that you may perceive to be not accessible, they actually are accessible to you in terms of general technology. Okay, so if the future is now accessible and solutions are available for every industry, the question then becomes, how can you benefit? How can your business benefit here in Northern Ireland? So what I'm going to show you now are just some examples. They're just really very few examples, just to give you a flavor of what's possible, to just stimulate your thinking a little bit. And even if I don't show examples of your particular industry, rest assured that there are solutions available for every industry. Okay, so this is in the construction industry. So the image on the left, the dog-like image, and as Andre was saying, a lot of these robots now are multifunctional. So the carcass, the framework of the dog can be used for any particular thing. But the way it's set up here, it's actually for the construction industry, for project planning and for project management and for quantity surveying. So as a building project is going on, this dog will roam around the building site, constantly feeding back live information into a live project plan and into a live quantity surveying plan, and also looking out for health and safety issues and what have you. But it means that then the supply of goods and services to that construction site can be made in a just-in-time way, because you have reliable, accurate live data. You're not waiting on an end of day meeting or an end of week or an end of month meeting of all the stakeholders. This little dog has captured all that in real time. Top right, that kind of white lorry with the big arm, that's also a robot and a fantastic piece of machinery. What it does, you lay the foundations of a building, Then you scan the plans of the building into the let's call it the truck, into the truck, and then it lays all the blocks. It builds the whole house. You know, it builds all the walls and everything. And it's currently doing 300 blocks an hour. And that's without using traditional cement. They have a proprietary type of bonding, a type of glue. So look how clean the site is. You know, there's no scaffolding, there's no mess, there's no health and safety issues. So then after those block walls are built, think how easy it is for the other trades to come in and lay the pipe work and the electrics and all the rest of it. And then bottom right, this little spider guy. Now, that comes in different sizes. And again, back to Andrea's point about the robots becoming more multifunctional, all the legs and of that little spider can be detached, and he can have different tools added to him. So it's very good for like surveying, maybe surveying pipe work, crawl spaces, roof spaces, anywhere there's tight spaces. That little robot can go and it can crawl over any type of terrain, and it can take images and video. I think it was last year, if I remember correctly, it was in London. There was a big gas explosion, and they later found out that that was caused because there was a very, very small burst in a water pipe, and that small burst, tiny hole, the jet of water that was coming out of that water pipe was pointed directly at a gas pipe, and over a period of, maybe they don't know how long, could have been a period of years, it had put a hole in the gas line, and that caused the explosion. So that little spider doing, you know, regular maintenance, regular surveys could have spotted something like that. Okay, so more construction. So bottom left, the pink robot. So this robot is actually plastering the walls, and there's a whole series of that type of robot that will basically finish off a building, from plastering the walls to sanding the walls to painting the walls to tiling the walls to tiling the floor, and they're all built to be, you know, quite small, so they can move around a residential home or a small residential apartment. Top left is a similar robot that's actually there. It's sanding the walls, but that same robot will paint the walls. Then in the middle, these robots are made for demolition. So if you think of normal demolition, you might think of a big ball and chain. You think of loads of dirt, you think of loads of rubble, you think of loads of dust, you think of lots of danger. Well, these robots basically eat the concrete, and they eat the concrete and turn it into gravel. Then they suck it out and it's put into bags so it can be recycled. And then all the remaining the metals and wires, and here within that picture you see the metal that's left after they remove the concrete, that can then be safely removed and recycled. So no dust, no dirt, no danger, no health and safety issues, and you can recycle everything. Top left, or sorry, top right, an interesting one. This one's laying bricks rather than laying blocks, and it's laying the bricks using traditional mortar. Now this is currently doing about 1,200 bricks a day. The really interesting thing about this, look at the floor, look at what it's sitting on. It's actually on scaffolding. So this is not a big heavy unit. This is not like a big truck. This is a relatively small light unit that can be lifted up safely on the scaffolding. And as I say, it's currently laying about 1,200 bricks per day with traditional mortar. Then bottom right, Dusty, looks a bit like a vacuum cleaner, but he's not. So what Dusty does, you scan in after, say, you've built your foundations, you scan in the plans, and Dusty draws the plans on the floor so that the other trades and the other robots can build what they see. They know where the drainage has to go. They know where the plumbing has to go. They know where the wiring has to go. They know where the internal walls have to be built. And it's 100% accurate. Let's see what else we have. Okay, hospitality. So top left, I remember being in Japan, and it's at least 10 years ago, maybe 12 years ago, and these type of concierge robots were commonplace in most hotels and even most restaurants. So you could do like early check-in, early checkout. They would give you directions to your room, direction to the restaurant, that sort of thing. And then now the robot in the middle, this, let's call it the waiter. These are really, really common now and quite cheap. So you go into a restaurant, you place your order either on your phone or via a tablet that's provided at the table. And then the food is prepared, and this robot waiter takes the food to your table and your drinks, and it also takes your plates away, once you're finished. The robot on the bottom right, also quite interesting. So this is a robotic arm, and the situation here is that it's in a type of a fast food restaurant. So think fish and chips, burgers, fries. It's that type of diner setup. So the robotic arm actually cooks the food, and it cooks it perfectly, consistently every time. And the interesting thing about this particular restaurant is that no humans are involved in the cooking or serving of the food. So the cooking of the food is done by these robotic arms, and the serving of the food is done by those type of waiters. The only place humans are involved is in the preparation of the raw foods, and that's it. Okay, so top left, so warehousing, there's a whole host of possibilities when it comes to warehousing, but the general message is that in terms of picking and packing, in terms of accuracy, consistency, working at height, safety, all those issues can be resolved with a whole range of robots that are designed for warehousing. Bottom left, this is a photograph, as you see, from a food hall, from basically a supermarket. And there's three types of robot in that picture. The first one with its hand stuck out is a concierge robot. So just, saying hello, directing the customers, etc. The one furthest on the left, that's a bit like the waiter one, but this effectively is your shopping basket. So it will accompany you around the supermarket. And as you select your products, you just put them on that, and that's your shopping basket. It'll take your goods out your car for you. And then the little one in the middle, that will, know who you are, know what your likes are, your dislikes. It'll tell you about, special offers, nutritional information, meal planning, and of course you can pay. You don't have to go to a checkout. You don't have to queue up. You just pay, and that's it. Um, the large picture on your right, there's another little bit of an unusual one, in that this robot is designed to do a very tricky thing. It's designed to stack shelves in a retail environment. And even if you look at the picture of the goods that's on display behind the robot, they're all different shapes, they're all different sizes, they're all different textures. But yet that robot can sense those things and can quickly and accurately stack those shelves. Interestingly, 1989, BMW, the other thing they do over there, that 6 weeks a year, they close the factory down. There's a huge factory, many thousands and thousands of people there, and they close it down for cleaning. And they clean absolutely everything, every nut and bolt and screw, and even the drain pipes get cleaned. And I was fortunate enough to get access to the famous M division, so the BMW M badge. And I went to a place where they manufactured the engines, the M series engines, and it was really like a laboratory, not like a production line. And if you see the image on the top left, the little carts with the wheels, well, in 1989 in BMW, they had little carts like those. They weren't fully autonomous. They kind of followed invisible to the human eye, little tracks on the floor. But what their job was to make sure the right component parts went to the right workstation at the right time. So when you seen them moving, it looked like they were fully autonomous, but it was kind of that type of little cart. Fantastic to see. So these robots, so the top one's kind of in a horticulture environment, but if you look at the robotic arm, obviously it's picking up something that's very, very delicate and valuable in terms of you don't want to damage that, but yet that robotic can do that. It's so sensitive, it can do that. The bottom left, that's a security robot, and that picture's taken in an airport. So that robot is scanning, facial recognition. It's also sensing for anything that would indicate, illegal material or whatever. So it's like pre-scanning people so that it's an extra security measure, but it'll also hopefully alleviate queues once you get to the likes of the main security gates. The dog-like robot, again, these dogs are very flexible in what they can do. This particular dog is set up for security. And so if you have any sort of facility or any space that needs you need to monitor it. It could be a playing field, it could be a public park, it could be a warehouse, it could be an industrial center, it could be a factory, it could be a shipping yard. Both the dog and the picture on the far right with the wheels, they're security robots. So they can simply roam around that space. They have night vision, they have sensors that'll detect movement, and they're continually taking live feedback to a data center. So they're essentially used for those three robots at the bottom. They're essentially all used for security applications. Okay, so it's all a bit mad, but I hope that by showing you those things, it just will make you realize, give you a flavor of the possibilities. And as I say, even if I haven't covered an example from your industry, please rest assured that there are solutions for your industry available and accessible today. Now, this is Bandside Pharmacy, Portlanone. It's a very busy pharmacy. It's been around for over 60 years, doing a fantastic job serving the community. And like all pharmacies now, they're very busy. There's, a lot of the GP type services have been, filtered down onto pharmacists. There's more, our population has grown and there's a higher demand on the pharmacies all across the country. So they're really under pressure in terms of getting the drugs out to the right people and then providing all the other services that we rely on the pharmacists to do. And of course, then, they had problems with overstocks, understocks, aged stocks, all these sorts of problems. So let's see what the solution was. So on the left-hand side of your screen, you're looking at the insides of a robot. And basically, this is the best way to think of this is like a very, very, very smart vending machine. So the doctor prescribes the prescription to the patient. Then the pharmacist will make up that prescription to make sure it's medically correct as per the doctor's instructions. Now then they deposit that in this super vending machine, for want of a better word, and then the patient can simply pick up their prescription any time of day or night. And the results of that have been really fantastic. They're now doing over 200 packages a week are being collected through that machine. And don't forget, the pharmacy's still open. They haven't closed the doors and chased patients away. This is in addition to the people who are coming into the pharmacy, but it has meant that it's saved a lot of human resources, and they can then better serve their customers with other things. It's protected the staff, it provides them with important data, and it has really improved patient care because now there's no delay, waiting on a prescription. There's no looking up to find out what pharmacy is doing a outer hours rota and having to drive to the next town or village. So from that point of view, it's been a real game changer. So I hope you have a little flavor, and I hope you believe that your future is now, and as I say, rest assured that solutions are available for your industry. And the only question is, what's holding you back? Thank you very much. Back to you, Andre.
Thank you, Jim. As I wrap up and I speak about whatever support is available, I would also like to invite you to drop any comments, questions that you may have in the chat, and we'll pick up on those in 1 minute. But until then, so you can find support relating to the Digital Transformation Flexible Fund in multiple sources. Any further education college across Northern Ireland, Queen's University Belfast, the Smart Manufacturing Data Hub at Ulster University, your local authorities through their enterprise support service, Innovate NI, and any other source of support that you can find. You can draw on it to figure out where you can improve your processes, where you can use smart technologies to generate value for your customers. In terms of the application process and further support, you can also access the DTFF website. Queen's University also offers support to businesses. We have a business clinic where which can provide your organization with a bit of consultancy support. We have a data analytics support where a duo consisting of a faculty member and master student can provide business analytics support and can generate some useful reports for you. The Clinton Institute also is a great source of help. They have open or customized courses and programs that can help you and you train your upskill your staff in the context of the digital transformation. Right. So. Before I close, just some quick reminder about the upcoming webinars. So 11th of June, AI and machine learning, 18th of June, immersive technologies, And finally, the workshop on how to design your digital transformation strategy on the 25th of June. And yeah, if there are any questions, I'm happy to, and I think Jim also, we're happy to take on your questions. Okay, so. Yes, Rod, as I said, right, whenever you're talking about adopting these smart technologies, robotics and so on, you will have to look at your value chain, or whether you have a production line, and figure out where is it that your pain points, where is it that the most difficult, the challenging stuff, the challenging task that you are struggling with, the task that's the most time consuming, the one that requires either strength, endurance, or mainly accuracy and consistency. That's where you start. And then you start looking whatever robotic solutions might be available that fit into that scope, where the scope of the task that you need you need developing. And from then you figure out whether that is economically viable, and how does that help you draw competitive advantage. I hope this addresses the question. Anyone else? Well, if yes, if there aren't any questions, and you're not checking the chat, well, this presentation is or will be available shortly on the Clinton Leadership Institute YouTube channel. So you can go back to this resource anytime you need it for your application or expression of interest for the DTFF funding scheme. Well, if there are no further questions, then let me thank you for your time and for joining us. And I do hope that this was useful for you.